or tomorrow, I don't care. I'm going to be like, it's their fault, it's on you all. Tomorrow, 8 a.m. in my mailbox. All right. So up until this point, you guys have talked about one kind of integral. There's only one flavor that you're aware of, and that is the definite integral. My question for you all, what is a definite integral? What does it mean? What does it look like? How do you know when you see it that it's a definite integral?
An area bounded by the f of x, x-axis, and...
Well, let's start with the notation. If you were to write a definite integral, they all have the same form. They all look something like that. Right? And there's those guys over there, some fancy vocabulary here, the A and the B, what do we call them?
Limits of...
These are the limits of integration. Okay, great. Got the limits of integration. The f of x and the dx, we call that the...
Integrand.
Oh, so awkward. Only Anthony's brain is working. It's the integrand, right? And Brian, what does it actually mean? I care greatly about what does a definite integral actually mean. Take it away.
The function with respect to x.
Well, that's how you would read it. You would say it's the definite integral from a to b of f of x with respect to x. That's how you would read it. But my question is more of a fundamental one. What does it actually mean? Only one person out of 6. That's not possible. We did this so darn much. You know exactly what it means. It means area. Okay? Okay, so basically the question is, what is the area? Give me some more. Bounded by, bounded by some stuff. Bounded by what?
F of x.
The function f of x. That's one thing. There's 3 more.
X-axis.
The x-axis. Nathan, give me something else.
Respect to x.
With respect to x, yes, but what are the bounds? There's the function, that's a bound. There's the x-axis, that's a bound, but there's 2 more bounds. 2 more bounds.
From A to B.
From A to B, but it's like the
Vertical bounds.
the vertical lines. Okay, and the vertical lines, x equals A and x equals B. If you need a little visual, here's f of x, here's x equals A, here's x equals B, and what's all the area? We have lived on this side of the house for the last couple of weeks. Truly, the last couple of weeks. Finally, I get to introduce you to my friend, the indefinite integral. And here's what the notation looks like. Big reveal. Here it comes. It's going to blow your mind. Boom, there it is. It is the indefinite integral, the obvious thing that is different. Nathan, what's the obvious difference here?
The limits of integration.
The limits of integration, there are none. There are no limits of integration over here. Definite integral, you have a definite, I think of it like a definite start and a definite end. Indefinite integral, there is no start, there is no end. Just like me. The question that's being asked here is, what function has little f of x as its derivative? Okay, the f of x, we're still going to call f of x and f of x with the dx the integrand. But these are indefinite integrals now. Your answer is going to be not a number. It used to be a number over here in the indefinite world. We're talking about a function. Big picture, is everybody okay? I want functions. Now, there will be all sorts of rules, all sorts of little quizzes that we're going to do to help get you to memorize these things. Today's not about that. I've got a few more notational things. The way that we're going to refer to the answer to an indefinite integral is we're normally going to call this, big surprise here, big F. We've seen big F before. We call big F the antiderivative. That antiderivative name is not an accident. Anti like opposite, right? Anti like antimatter. f of x is the original function. This is the antiderivative. We're undoing the derivative process. I will tell you one thing, and this might make you scratch your head a little bit. I need you to introduce you to my friend Charlie today. Charlie. Charlie is known as the constant of integration. Okay. We'll talk more about Charlie in a little bit, but I just want you to know right now that Charlie is a constant, but it is a constant that you might not know. We're going to call it the constant of integration. Everybody okay so far? Okay. Do me a favor. Take a moment. Explain to somebody near you what's the difference between the definite and the indefinite. See if you can do this without looking at your notes.
Indefinite has no limit, no boundary, and instead it tells you what function has f of x in, yes, in its side. That's very good. Yeah.
Okay, so what's the difference?
No limits of integration.
No limits of integration.
And with indefinite, we're trying to see which equation has f of x as its derivative.
Right. I'm going to give you the integrand, and the question is what function has the integrand as its derivative? Okay, that's the question. Victoria, you okay? All right. No rules today, just instinct. Trust your instincts. Okay, we're only going to do like one or two whole group, and then I want to give you guys some time to play. You're going to argue a lot, and we're just going to see. Trust the instincts. This first one is meant to be the kind one. I'm going to read this as the indefinite integral of 6x minus 2 with respect to x. But the question that I'm asking you, Roger, what's the question?
What function has f of x? That 6x minus 2 is its derivative.
So ask yourself that question. This is the derivative. What function did you start with? What function did you start with that gave you 6x minus 2 as its derivative? That's the question. Ponder on that a little bit. What function has 6x minus 2 as its derivative? Do a little bit of reverse engineering here. What would you have started with to get 6x minus 2? I know when I take the derivative, I bring the power down and I multiply and I reduce the power by 1. So if I'm getting 6x as my answer, what must I have started with?
3x squared.
Everybody okay with the 3x squared? I'm just doing this one part at a time. What would I take the derivative of to get negative 2?
Negative 2.
Negative, is everybody okay with this?
Yeah.
Okay, no rules, this is just doing like the puzzling. Now here's the thing. This is an example of a function that has 6x minus 2 as its derivative. Anybody else know another one? Yeah.
3x squared minus 2x plus c.
Oh, okay, now you just cheat. How about 3x squared minus 2x plus 4? Does that work?
Yes.
Brian, why does that work?
It still has the derivative of 3x.
Right, the question is, does this guy have 6x minus 2 as its derivative? Yeah! 3x squared minus 2x plus 4, derivative of 4 is 0. Great. Victoria, can you think of another function that has 6x minus 2 as its derivative?
I'm not sure.
Okay. Brian, can you help her out?
So what's the question again?
Another function that you can think of that has 6x minus 2 as its derivative.
3x squared minus 2x plus 6.
3x squared minus 2x plus 6. Victoria, does this guy here have 6x minus 2 as the derivative? Derivative of 3x squared, 6x. Derivative of negative 2x, negative 2. Derivative of 6? 0. So can you give me another function that has 6x minus 2 as its derivative?
X to the power of 6.
So let's stop and think for a second. If you take the derivative of x to the 6, what's that derivative going to be? The derivative of x to the 6 is going to be 6x to the 5th. Is that what I want?
No.
No. So Anthony, give me another one.
3x squared minus 2x. Plus 6
Plus pi squared, love it. Love it. Derivative of 3x squared, 6x. Derivative of negative 2x, negative 2. Derivative of pi squared, 0. So why am I going to push this idea of like Charlie? It's 3x squared minus 2x plus any constant factorial. All you need to do, like, once you've got like the function piece, any constant added on to the end of it or subtracted from the end of it, when you take the derivative, you're going to get the same guy. What I want to see, this is like back in like 3rd grade when you first learned about division, I want the check step. How are you going to check it?
Find the derivative.
Find the derivative of whatever you're giving me as your answer, okay? So what I want to see though, I want to see written down, I'm taking the derivative of 3x squared minus 2x plus Charlie. Let's see, take the derivative. 3x squared, 6x, minus derivative of 2x, 2, plus the derivative of Charlie, 0. Does that work?
Yes.
Yeah, buddy. Okay, show what you can do with the next one.
Oh Lord.
Oh, we need to put the 0.
I mean,
Lord Jesus bless.
the best answer is going to be this guy over here.
The other ones that are right there. Is he in this one?
Yeah.
Yeah,
Okay.
problem number 2. So this is what's in.
What's the derivative of cosine?
The derivative of cosine, yeah.
Yeah. So I got one down there.
You're going to take my folder from me?
Yeah.
Cos t squared.
Oh yeah.
Do you know how to do
16.
the It's gonna be 10. This is how I'm.
Is he 2 power 5? 2 times
You have to
5.
have 2 at 5. Because you know that that's gonna make the 5 come down. It's gonna be 5 times 2. So you need to take out the 5. And then
I don't know how to do the first.
You say cosine t squared?
Yeah.
Okay. 2 times e plus 2.
Is anybody comfortable with any part? Any of the 3 parts? Give me one part.
10 e to the power of 5t.
So you're saying it's going to have to start with 10 e to the power of 5t, and why are you thinking that?
If I know, like the derivative or the antiderivative of e to the some power is e to some power.
Okay, so like somewhere in your brain, you know that the derivative of e to the x is e to the x, right? Okay. Anybody else think they know another part of this?
6 plus 16.
Okay. Plus 6t. Check. Yep.
Negative cosine 2t divided by 2.
Negative cosine 2t divided by 2. And plus Charlie. Now, I am not saying that this is the right answer. I am absolutely not saying that this is the right answer. We're going to go over to the check step. This is how you're going to build up your skills. So let's do the check. I'm going to find the derivative of 10 e to the 5t minus cosine 2t divided by 2 plus 6t plus Charlie. When I take the derivative of 10 e to the 5t, if I'm going to do this the right way, I'm taking the derivative of 10 e to a power. And the derivative of 10 e to a power is 10 e to the same power. That looks good. That looks good. But then we run into a problem. You have to do a chain rule, which means you have to multiply by the derivative of 5t, which is 5.
Oh.
Now this part over here, minus the derivative of cosine 2t, that's really negative sine 2t times 2 divided by 2. Maybe that's not so good, not sure. Plus 6, what do we think? We got it? We didn't find the right antiderivative?
What if we left it as plus cos?
Let's see. Is that what I want to get to? We're just going to play around with this a little bit. Is that what I wanted? Did I get my 10 e to the 5t when I took the derivative?
No.
No. What I really got was I got 10 e to the 5t times 5, 50 e to the 5t. So we've got to fix this. How are we going to fix it? So we get 10.
10 e to the 5t divided by
10 e to the 5t divided by 2.
Wait.
Yeah.
So we go back to the first one and then go to 2e to the 5t.
Does that work? Does 2e to the 5t have the right derivative? My goal is to get 10e to the 5t. If I had made this 10 a 2, then I'd have 2 times e to the 5t times 5. Is that what I wanted to do? Absolutely. There are rules, there are formulas, they are coming. Not today, though. Today is just developing your instincts a little bit. Now, Lucio gave us negative cosine of 2t divided by 2. Does that actually give me the derivative that I want? It does. Let's see.
Well,
No, because that'll give you positive sign.
The 2's would cancel out. That's a good thing. The negative of the negative is positive sine 2t.
I thought it was an effect.
Okay. That is, yes, we will question you from time to time. Okay? And the 6 is the easy part?
Yeah.
Okay. All I want you guys to do is to be able to get some playtime with this. So your final answer is 2e to the 5t minus cosine 2t over 2 plus 6t plus Charlie. Most likely in a lot of these problems, the coefficients are going to cause some problems for you. And which is why I want to see the check step, and you're going to go and say, oh, I'm off by a multiple of 5. Let me divide by 5. Oh, I've got the wrong sign in front. Let me go fix this. One last thing that we may or may not have talked about. If I start with the sine of x, what's the derivative?
Cosine.
If I take a derivative, I get cosine. Take another derivative.
Negative sine.
Negative sine of x. Take another derivative.
Negative cosine.
Negative cosine of x. Take another derivative.
Sine.
Sine.
Positive sine of x. When I'm going in this direction, we're taking derivatives. Anybody know the antiderivative of sine of x?
Negative cosine.
Negative cosine of x. Antiderivative of negative cosine of x?
Negative sine.
Negative sine of x. Antiderivative of negative sine of x?
Cosine.
Positive cosine. Antiderivative of cosine?
Positive sine.
Positive sine. When you're going this way, we're talking about integrals. We're talking about antiderivatives.
Oh,
Okay? So I want to give you guys 10 minutes. Show me what you can do with problems 3 through 10. We'll check in. We'll have some good conversations about this. And then I'll throw you into some of the hard problems. Building up our instincts. I want to see the checks. There will come a time where you don't have to show me the check step. My hand hurts. I checked it in my head. Isn't that good enough? It sure is. That's what Caroline hopes I would say sometimes. Chance over. 3x to the 4th. Are you convinced that that's going to give you the correct derivative?
I don't know if we did.
Good. So the derivative rule says bring the power down and multiply. Reduce
Yeah,
the
that's what I'm saying. I don't know what that is.
next here. How about this x to the 4th?
Because it'll be x to the third degree.
Yeah.
Is there any part of it that you do
Oh,
know?
what about 1/4 x?
How could you ever get x to the 4th as a derivative?
X to the fifth over 5.
Mhm.
X to the fifth over 5. Because it'll be 1/5.
How did you get 3x to the 4th?
X to the 5. So bring the 5 down.
Yeah, sure.
But you know that when you take the derivative, the exponent becomes smaller by 1? So with the
To the fifth
antiderivative,
over 5, right?
it goes up by 1.
Huh?
No,
So you- I mean,
because
when you
once we
said
find the derivative of this,
Yeah, I would think that this
would
was
be a whole
five.
different
but
Right.
then-
Huh?
But now you've got to figure out what.
Oh,
So
that's-
you get
Right.
12x.
if you guys can just subtract it.
Forgot about the
That's
C
how much
man.
I would fail.
Hey, don't forget about my friend Charlie.
Yeah.
What if we
Oh, amazing.
for all of them we had to put C?
And only the ones you want to get right.
I'm not really clicking this one. I don't know.
Okay.
1/5 x to the 5th.
Okay. So from walking around, it looks like everyone's good with the 3x to the 4th.
Yeah.
And the pi x.
Yeah.
And the char. Yes, ma'am.
Yeah.
So in between would that be 1/5 times x to the power of
I
To the 5th
completely
power?
agree with you. What I hope everyone's feeling good with is if I'm getting x to the 4th, I must have started off with an x to the 5th. Right. What makes this a little bit harder, though, is you've got to think, but wait a second. How am I going to get negative 1x to the 4th if when I bring the power down and I multiply, right, I'm going to bring the power down and multiply, I've got 5. What would I multiply 5 by to get negative 1? Negative 1/5. There is no point in this problem where I'm telling you the coefficients have to be nice numbers.
Oh, is it? You wouldn't change it because you multiply by a constant, right?
Right, when you multiply by a constant, you ignore the constant in front and you just say, oh, so negative 1/5 times the derivative of x to the 5th, the derivative of x to the 5th is 5 times x to the 4th.
Yeah.
So when I go over here to my
Yeah,
check
but you-
stat, my derivative,
So, remember.
3x to the 4th minus 1/5 x to the 5th plus pi x plus c, I get 4 times 3x cubed minus a 5th, 5x to the 4th plus pi plus 0. That does simplify to 12x cubed minus x to the 4th plus pi. Great. Keep going. Keep going.
Be negative close. No. I got it.
Roger, what do you have for number 4 here?
Negative cosine theta plus sine theta.
Negative cosine of theta plus sine of theta plus c. Okay, so let's go over to the check step. Convince me that you're right.
The derivative
By getting trouble. Getting trouble.
with respect to theta,
Yeah.
negative cosine theta plus sine theta plus c. It's gonna be sine theta.
Okay, because you've got negative the derivative of cosine, so that's negative sine theta plus
Cosine theta.
cosine of theta plus 0 sine theta plus cosine theta. Good. It's all about learning to undo your derivative rules. God, there are some other derivative rules that we memorized that I said I really want you to know these because they're going to come up again and again and again and again and again and again and again. Yeah, gosh. Anybody know anything that has 1 over 2 square roots of x as its derivative? Not you, you're frozen for a little bit. Keep playing. Play by yourself. What on earth would have 1 over 2 square roots of x as its derivative?
Square root of x.
Square root of x. What on earth has 1 over x as its derivative?
Yeah.
Natural log of x. Now, you're going to think I'm going a little bit crazy here? No. We're going to write natural log of the absolute value of x. Because the natural log function has a domain restriction, you might just want to put a star next to this one right now. We can only ever take the natural log of positive values, right? That's all I can ever work with. There's no domain restriction over here other than x cannot be equal to 0 because I don't want 0 in the denominator. To account for the fact that x's could be negative or x's could be positive, I'm going to have to use the absolute value bars around that. Okay, go on. See what you can do. Derivative square root of x, 1 over 2 square roots of x. Derivative natural log of x, 1 over x. Gosh, I wonder if there are any other ones that I'm supposed to just have memorized at this point in my life. Is that another
The other one was like for
No, it's 5. It's 5.
Oh, the thing that I'm not sure if it's an integral, an s, or a 5. That's a 5. Okay.
5
5 times negative cosine of x.
Yeah, I don't know.
Oh, good. I'm going to let you dangle for a little bit. Look at how the rest of us live.
Oh, wait a minute.
Oh, that's his word.
No, stay with us. Yeah.
Antiderivative of 5 sine of x minus sine of 5x. Antiderivative of 5 sine x. What on earth would I take the derivative of to get 5 times the sine of x?
Negative 5 cosine.
Let's see. All right. Convince me, Anthony. Does that actually work?
Wait, no. What I was trying to say is 5 times negative cosine.
Okay, so you want to do 5 times negative cosine?
Yeah.
You're going to realize that I've just erased and rewrote the same thing.
Yeah.
Yeah.
Okay? First of all, convince me that that has the right derivative.
5's a constant, so you're just going to keep it there.
Leave it alone.
And
Derivative
then-
of negative cosine of x is
Sine.
positive sine of x, so this works, right? What did I write the first time though?
Negative cosine.
I think I had negative 5 cosine of x. Now, minus sine of 5x, this is meant to be a little bit trickier.
I have a question about that.
Yeah.
So if we had negative 5 times cosine of x, when do we find the derivative of cosine of x? And what does that mean? Over here, cosine of x.
Okay, so it was really just a question between you and God. Okay, so you found the antiderivative of the first part, minus, now what would I be taking the derivative of to get sine of 5x?
Was cosine?
Right, if at this point, if all you know is, okay, like I know some pieces, right? If I'm gonna get sine as the derivative, don't I have to have started with cosine? Sure, anything else that you know for sure?
1/5 has to be
Maybe you get the 1/5 right away. That most people don't actually get the 1/5 right away. The thing that I would hope that you remember is that when you take the derivative of sine or the cosine, the angle never ever changed. The angle was the baby. So over here, it has to be cosine of 5x. Now think about moving forward. Think about finding the derivative. Derivative of cosine is negative sine, hey, I like that, of 5x times 5. I don't like the times 5, so the way I'm going to adjust for that, I'm going to divide by 5, which is what we were doing over somewhere else, or you just say minus 1/5 time. I'm a much bigger fan of multiplying by constants than dividing. And then plus Charlie. More fun ones. More fun ones. All right, antiderivatives. Antiderivative of e to the x. You guys know this one?
E to the 2.
E to the 2 pi should have. Antiderivative of e to the negative x. What have you ever seen that has e to the negative x as its derivative?
Negative 1 e to negative positive.
Let's see, the derivative of e to the negative x, and maybe we're just making like a running list, like what are all the things that I'm supposed to remember? Derivative of e to the negative x is negative of e to the negative x.
Yeah.
So how am I going to get positive e to the x as the derivative?
Negative.
With a negative e to the negative x. There, got it. What would I take the derivative of to get e to the 2x?
To 2x.
It's going to have to be an e to the 2x because when I take the derivative of the exponential, the power stays the same, and I multiply by the derivative of the power. I'm multiplying by 2. I don't like multiplying by 2 because that's not in my integrand. So we're going to say plus a half plus Charlie. All right, another round of 10 minutes. Show me what you guys can do on this next batch. Yeah. Yeah, for 8, 9, and 10, show me what you can do.
Oh, wait.
All you've got to think about is you're undoing the derivative process. This is your fault. Why is it his fault? It's the last batch of problems that are his fault. And I mean, really, The last batch of problems were made up especially this morning for the 7 of you all. Why?
He doesn't know.
Because I have high expectations for you all. Too bad. Welcome to being raised a Roger. I'm not a DeRozier, I'm an Aguilar. If you don't figure out the pattern after number 8, you might never figure out the pattern.
Oh, wait.
Anthony, what's the antiderivative of t to the 5th going to be?
1/6 times t to the power 6.
1/6 t to the 6th. Everybody agree?
Sure.
Okay, Brian, what's the antiderivative of negative t to the 4th?
Negative 1/5 t to the 5th.
Negative 1/5 t to the 5th. Lucia, what's the antiderivative of t cubed?
1/4 t to the 4th power.
1/4 t to the power 4. Victoria, what's the antiderivative of negative t squared?
Minus 1/3
1 over 3
times t to the power 3.
minus 1 over 3 t to the power 3. Nathan, what's the antiderivative of t?
1/2 t to t squared.
1/2 t squared. Roger, what's the antiderivative of negative 1? Negative t plus Charlie. And if at this point in your life you want to stop doing the check step, I think that's okay with me. Figured it out?
Figure what out?
That there's some stuff. Your smarticle particles will be telling you some stuff. Enjoy.
Yeah.
Already solved the word.
Oh, wait, I know how to do it. Yeah, I found the pattern. Yeah.
How do you do it?
The chain will be
Yeah.
This is a chain. No. This right here is a chain. You get the chain of this. And power down 10 times this to power 4 times the derivative of this. Get it? Hold on.
Well,
It's a chain?
think about the check step. How
This
would
has
you
to
check
be a
that?
chain.
How do you know that's the
Mine.
Because what's the derivative of this?
You would find the derivative, and in order for you to find the
6 minus 2.
derivative, in order for you to find the derivative the right way,
Didn't this?
Yes.
oh my god, how bad would that be? Hey, come on over.
It turns to 2.
These are product. What's the product rule? I mean,
So, are you guys supposed to go to your
That's just it.
what's the charge of these two? Like 2
We had a product.
When you're in product square, what rule causes the things to multiply?
Remember again, trying to remember it's just this. Is it just this?
Seeing a whole lot of stuff like Chuck. You know, there's something that I notice here. I don't know if anybody else is seeing this, but I'm seeing this 3x squared minus 2x being kept very nicely inside the parentheses. And then I'm seeing the 6x minus 2 right out over here. And You know, there might be some sort of a connection between this 3x squared minus 2x and the 6x minus 2. I mean, some people might even think, like, well, if 3x squared minus 2x is this thing that I'm just going to call the baby right now, then, like, out here, 6x minus 2, what is that?
Baby of the baby.
No, I thought the answer was the most.
This is derivative of the baby.
Isn't that baby prime?
Yeah. Optimus Prime.
I've got 10 times baby to the 4th times baby prime. 10 times baby to the 4th power times baby prime.
That's my baby.
Isn't that what I would get if I was actually taking the derivative of 2 times baby to the 5th power?
Yeah.
Think about your derivative rule here. The derivative rule says bring that power down in front. 5 times 2 is 10. Baby to the 1 less power times baby prime. So the antiderivative here is really 2 times 3x squared minus 2x to the 4th plus Charlie.
Wait, wait to the 4th, do we to the 5th?
Yeah, that 2 to the 5th power.
And what about the 6x squared?
What about the 6x? What about the 6x minus 2? Yeah, good question. What about the 6x minus 2?
Wouldn't that just be 3x squared minus 2x?
Think chain rule. Think about your checks.
Oh! Yeah.
5 times 2 is 10. 3x squared minus 2x raised to the 4th times the derivative of the inside. Hey, there it is. Keep going. Keep going. You keep going too.
You know, I just wonder, what's the antiderivative of arctangent?
What's the antiderivative of arctangent of x? That would be... The answer's 2.
Divided by 5.
Arctangent of x minus... You'd have to do integration by parts, which is so far away. So far away. Okay, so what is it that you saw here? Right. It's the result.
The result of the product.
Good. Keep playing around.
So this right here.
This has got to be a product rule.
Yes! Sorry. Does it have all the right players to be a product rule? You get addition. Right, if you get it, but you got to think about this in the right way. The product rule says you take the derivative of the first times the second one. Plus now it's the first one that gets left alone times the derivative of the second. Does that work? Well, check it. This is the result of a product rule. You just got to figure out what are the right functions. Product rule would tell me derivative of the first times the second plus the first times the derivative of the second. So cosine of x is not the first function, it's the derivative of the first function. So sine of x times natural log of x would be the second function that you leave alone. Plus, now it's leave the first one alone times the derivative of the second one. Yes. Okay. Roger, you okay? All right, this next batch of 8, if you can even get 3 or 4 of these, you're in a really good place. These are definitely extra innings. I've never put any of my other calculus students at this level of problem on day 1. I'm looking for you to get really clever here. Trust your smarticle particles. Yeah.
Check number 1.
Can I check number 1? So what have you done here?
No,
is that leaving?
Okay.
So you said x over x squared plus 1 over x squared dx. Now there's some stuff here I like. Some stuff here that I don't. The antiderivative of 1 over x is natural log absolute value. Does
Is the derivative of negative 1 over x positive 1 over x squared?
The question is the derivative of natural log of x 1 over x? Yes. Is the derivative of negative 1 over x positive 1 over x squared?
Of negative 1 over x.
Is the derivative of negative 1 over x 1 over x squared? And this would be the wrong answer.
Negative.
Right, that's why I keep asking, is the derivative of negative 1 over x equal to 1 over x squared? Let's see the question mark. Wait,
I'm not gonna go much with that.
yes, it is. So this is right. Okay. There you go. There you go.
And
You
it's
want
low.
me to do it quick?
Huh?
Yeah.
Another low.
It's the hardest.
Minus 5, which
Did you remember to write plus Charlie yet? How about for number 3 as well? Okay.
So what clever thoughts do we have? I basically just distributed this.
Is that legal?
Yes.
Absolutely. Algebra stuff is legal stuff. So you're rewriting the integrand as x cubed minus 4x, and then go find the
So,
integrand.
cosine squared plus sine squared equal 1.
How we doing? Well, let's not worry about this one. So wait, try number 2 here.
Cosine squared
You're the ones I can find the most for you. 2.
Plus sine squared is.
1, right?
That's what I'm asking.
That was focusing on 3. So focusing on 2.
I promise you, for all my rule followers, rules are coming.
Okay.
Today is just pushing your thinking process. The rules are coming. But you also have to trust your instincts here, because there are no rules for handling x plus 1 over x squared, but there might be cleverness out there. Okay. Anybody thinking quotient rule? Maybe you're thinking quotient rule? Quotient rule, low d high minus high d low, low, low. That seems a whole lot to ask from this little guy over here. Now, but maybe it is a quotient rule, maybe it's not. So if I can't get quotient rule going on there, I might start thinking, are there other legal things I could do?
By x squared.
I don't want to multiply by x squared because this is not an equation. I don't have this equal to something and I'm like multiplying by x squared. But how about rewriting it as x over x squared plus 1 over x squared? My first question for everybody is that legal? Okay, second question, really important one. Does this make life better? X over x squared, is that better? What is x over x squared?
1 over that.
That's really 1 over x plus 1 over x squared. Does anybody know the antiderivative of 1 over x? Said another way, does anybody know a function that has 1 over x as its derivative?
Square root of x.
Not square root of x.
Absolute value.
Careful.
But I know that.
What has 1 over x as
Oh,
its derivative?
natural log of x.
It's natural log of x, right? This is, all the ideas are there, but you're learning to go backwards, and this is the hard part. So it's natural log of x, but it has to be the absolute value bars. I think that's why you had the absolute value bars floating around in your head. Plus, does anybody know a function that has 1 over x squared as its derivative? 1 over x squared. There was something that you guys knew once that was almost 1 over x squared when you took the derivative.
X, so negative. X over x.
Something, because, okay, this is how I think about it, it's x squared, right?
Yeah.
And so if we want to work backwards,
No, 'cause then
that
that'll be
somehow
changed.
turns to x to the power of negative 2.
If we leave it like that, that would be a
And
change.
then I will add a number to it,
Yep.
so x to the power of negative 3, and that's
This
what
means
I'm...
that
Ooh,
isolate
so
the
close.
concept.
X to the power of negative 2 add 1 is x to the power of negative 2.
Oh, okay.
Okay, one of the derivative rules that you guys would have memorized a very long time ago, derivative of 1 over x,
Negative 1 over squared.
is negative 1 over, not square root. If the derivative of 1 over x is negative 1 over x squared. How does that help over there?
Could we say negative?
So a negative.
Minus over x.
So this is gonna be minus
1 over x plus Charlie.
Charlie gets something else.
Right, derivative of natural log of x is 1 over x minus the derivative of 1 over x. This is going to be a negative 1 over x squared. Minus the negative gives me the plus.
Whatever it is. Do you remember that?
Yeah.
Show them what you can do at 2, 3, and 4. Which ones do you guys prefer?
I just want 4.
Okay, so what are the thoughts?
I was like, well, distribute the two right here.
Is that legal?
Because you would have to do the box.
Right, so you're going to have to do the box. You want to do the box correctly.
So x times x is
Perfect. Alright, okay.
Which problem?
You're going to have e to the x times e to the x, which is e to the 2x. The bases are the same. You have the exponents here. Now, let's think a step ahead here. Will you be able to find the antiderivative of e to the 2x?
Yes.
So you know a function that has e to the 2x as its derivative. 1 e to the 2x.
Do we have two no, which box?
Here, I was in.
times x squared minus 4x. See, a lot of folks have multiplied out the x
The x squared minus 4.
Even if it's zero?
Okay. First one,
They're
legal.
the same.
Legal. Okay. And so the antiderivative of x cubed. What has x cubed as its derivative? What has x cubed as its derivative?
1
Right. The thing that I know for sure is it's going to have to involve x to the 4th
times 1
Times 1/4. Good.
Your fraction skills are going to come back and you're going to start to embrace fractions as the answers. Minus, what would I find the derivative of to get 4x?
2 squared.
It would be 2x squared plus Charlie.
Nice.
Oh yeah, no love to Charlie, like you forget.
Yeah, don't forget about Charlie.
Charlie Sheen.
Oh no, he's had too much love. That's his problem. Oof.
Great, and that's on film too.
Antiderivative sine squared x plus cosine squared x. What the heck is going on there?
No, I thought you did.
It's either really, really hard or nice job. You saw that one? Not loving number 4 though.
1?
Three. So Victoria, what were you saying about number 3?
Sine. 1. I don't know why, but I can't say it. It's not, the words aren't coming out, but I know when that has a row where it equals to 1.
Right, sine squared of x plus cosine squared of x is equal to 1. It's called the Pythagorean Identity. Right, that was one of those identities that you really needed to work on way back in the days of trig.
No.
The antiderivative of sine squared of x plus cosine squared of x.
Doesn't give me anything.
So I'm really just asking you to find the antiderivative of 1.
So x.
So what has 1 as its derivative?
0.
Not 0.
X.
Right. The question is, what would I take the derivative of to get to 1?
That's going to be x, but it's really x plus Charlie. Don't forget about Charlie.
Oh, this is
There you go. So what'd you guys come up with? 1 negative 2x minus 1 negative 2x minus 2x. Nice.
And for this one, we need to find the function of x.
Well, this is your integrand, so you're looking for a function that will give that to you as the derivative.
Oh,
Right, and so the
that's
secant
inside.
squared,
It's inside of it. I thought it was-
right, the secant squared is supposed to be a clue. Right, you guys know where secant squared comes from, the derivative world.
No. Remember this?
Oh, maybe you don't.
They might-
Remember how? No, we
There
don't
is a
really do
function that you know of that when you find its derivative, you
that.
get
Yeah,
secant
that's what I'm
squared.
saying.
Tangent. So the derivative of tangent is secant squared. I'm going to start thinking tangent of stuff.
We're not
Tangent of stuff.
here.
Mm.
So then there's a column.
Brian, are you and Anthony talking about number 4?
Yep.
Yeah.
Okay. So a popular idea is to do something like this: e to the x plus e to the negative x cubed
Yeah, we got to that.
times a third plus c. Totally popular idea.
Chart.
And plus chart. And this fails why?
If you do that, the derivative will give you that plus, you gotta do chain rule basically.
You have to do a chain rule. So the 3 and the 1/3, those multiply, that's good. 1 times stuff squared times derivative of stuff. And it's the fact that there's that derivative of stuff that says, oh, no, that can't work, so try other things. Try some other things.
It's just Charlie. Stuff plus Charlie.
Yeah, that would be smart though, just do that.
Stuff plus Charlie.
Oh, and you think that you get stuff.
Well, that's the answer.
Wait, write something.
To what?
To 6.
Oh,
So all of that,
divided
you just
by-
put plus C.
Something plus
Oh,
Charlie.
good, right, because partial credit, right?
Let me see if it's good.
Tangent of x. Oof.
Can we just rewrite to the sign of x times cosine?
I don't know about that. I don't know if that would be helpful.
Okay, never mind. So
Because then maybe you'd see the derivative of the baby and you'd see stuff, who knows?
Just each negative. And we
You did it.
I did not call
for
you.
this one.
You said the derivative of the baby.
Yeah, I mean, you, depending on
3 which cancel out.
how your brain's
Three bring
wired,
it down.
Yeah. you might think tangent of x is sine of x over cosine of
What did you
x.
get? Did you get this?
And that could be helpful.
Oh.
This is not clear on my mind.
How did you get that?
Especially if you think that cosine of x is the baby.
Oh, you can't do that because that's
It's
not
minus
the base.
5. Unless it's,
But it's also in the denominator.
so 1 of x?
Oh, you basically did x minus x, which gives you 1
And
squared.
then sine of x is at the top.
And I see you guys aren't going anywhere near 7 and 8.
So where's
Yeah.
this?
No. They're not like, these are not like terms, you can't combine them.
Did you notice he switched it up?
You would be able to say e to the x minus x if you were multiplying these two things together. E to the x times u to the negative x would give you the same.
I like this side.
Good.
But this,
You like this side?
like this
Oh.
too.
Multiply it out.
I did business
Oh, I love that. Okay, so the other strange
You're
thing
not
that
even
some
six.
teenagers think at a time like this is, okay, it couldn't have just been 1/3 all of this cubed,
Okay, fine.
because I would need
No,
the
I got the
chain
answer.
rule, right? And the chain rule would introduce multiplying by e to the x minus e to the negative
Something
x.
plus C.
So let me divide by e to the x minus e to the negative x.
That's
I understand why you're
technically
thinking that. Look at this with fresh eyes. Here's my question.
correct. A function.
How would you find
times
the derivative?
plus C.
Oh. Quotient rule.
Quotient rule and a chain rule. Good luck, sucker.
What's kind of sine of cos? What's something that would give you the derivative of sine of
Yeah, I don't think you want
Right?
I'm so confused.
Alright, so my friends that are over here.
So cos over
Tangent of x is really the same thing as sine of x over cosine of x.
so then the derivative of
Which I'm gonna write this way just cause. I'm gonna write it as 1 over cosine of x times sine of x. Oh, we're done. Is that legal?